Where do engineers and designers at companies like BMW, NASA, and Bosch get custom manufactured parts fast? Xometry. With Xometry, anyone with a 3D model can get pricing and order parts thanks to Xometry's instant quoting engine. Access dozens of manufacturing processes like CNC machining, sheet cutting and fabrication, 3D printing, injection molding, and more, along with hundreds of materials, all in a matter of seconds. Check out Xometry today at xometry.com. That's Xometry.com. Xometry, where big ideas are built.
I'll tell you what my career plan was. I didn't have one. All right. I did not have a career plan. It was opportunity, fear, and survival. Any one of those three defined my career.
Hello and welcome to the Being an Engineer podcast. Today we are privileged to speak with Jonathan MacWilliams. Jonathan holds a bachelor's degree in metallurgical engineering and has held positions from metallurgist to distinguished engineer at GE to Norman Noble to Mert Medical and now Edwards Lifesciences, where he is currently tasked with developing technical leadership and mentoring programs. Jonathan, welcome to the podcast.
Why, thanks for having me, Aaron. Glad to be here.
So I'll start with the same question I ask everyone at the beginning. What made you decide to become an engineer?
Well, let's put a little perspective on this. So I grew up on a small island in the North Atlantic called Prince Edward Island. It's the smallest province of Canada. And I didn't have much, I was a farm boy. My dad worked for the Canadian Broadcasting Corporation. I didn't really know what an engineer did. I had heard that they were the guys that wore the white helmets on the road crews and they were kind of, uppity and that sort of thing. But I really didn't know much about them. And it came time for me to go to college. And my parents were like, oh, yeah, you're going to college. And I'm like, okay. And I didn't know what I wanted to do. I knew I wanted to do something math and sciencey. But nothing really resonated with me until somebody told me about engineering. He said, engineering, you do the math and the science stuff, but you actually do some good with it. And I'm like, oh, I'll learn more. And next thing you know, here I am enrolled in the University of Prince Edward Island's pre-engineering program, and I did 3 years of engineering there. And it was a general program, It didn't tell you, like, you didn't pick it, you didn't lock in on something until after you were done, right? So I did pre-engineering at UPEI, and then I would transfer to either the University of New Brunswick or what was then known as the Technical University of Nova Scotia. I didn't like Fredericton, which is where UNB was, so I'm like, well, I'm going to Halifax to go to Tons. And I figured, well, I'll do mechanical engineering. And then I took dynamics. Dynamics is where they separate out the people that can't do mechanical engineering. So I was out. Like, well, maybe an electrical engineer. And then I took circuits, and that weeded me out of electrical engineering. And I'm like, okay, well, civil engineering's all that's left. And a buddy of mine said, there's this thing called metallurgy. And I'm like, oh, what's that? And yeah, it's like, well, the civil engineer designs the beam. Yeah. But what if you could pick the metal so the civil engineer can make a smaller beam? And I'm like, oh, that's kind of a neat idea. I'm all right with that. And so we went to the tour, the tour of the school. And one of the things they had us do they showed us was the thermite reaction. I don't know, are you familiar with the thermite reaction at all, Aaron?
I remember the name from college, and that's about it.
Yeah, so the thermite reaction is brilliant. It's how you weld rails together, right? In rail lines. And basically you take aluminum powder and you mix it with rust and you put a sparkler in it and you run, right? And what happens is the extracts the oxygen from the rust and leaves the iron behind. And it's fire and brimstone. It's amazing. And they did one of these in the parking lot. And I'm like, I'm all in. That's what I want to do. And so thus I became a metallurgist.
Okay, so that's one of my questions is I don't know much about metallurgy, and we haven't really talked about metallurgy much on the show, maybe once before. But this is a super open-ended question, so feel free to kind of take this wherever you want. What are just one or two interesting things about metallurgy that probably most other engineers don't really know about?
Well, so metallurgy is that bridge between the mine and the machine shop. Okay, so the mining engineers will dig the ore and get it ready to ship to the metallurgist. And then the metallurgist venue is from, okay, you've gotten me some ore, you've refined it a little bit. I'm going to refine it further, convert it to metal, then convert that to a semi-finished good, and then ship it to the machine shop. And then the mechanical engineer can take over and machine the stuff. That's part of it. And the other part of it too is the metallurgist is the guy that can go in and help you when you have a mistake. So the mechanical engineer knows all the mechanics and the dynamics and all that stuff anyway, he can handle that. But sometimes things don't work, right? It's like, this was supposed to work, but it broke. And the one thing that my true passion in metallurgy is fractography and failure analysis. Because if you have a piece of metal that has fractured, give it to a metallurgist that's got his wits about him, and he'll be able to tell you why it broke, where the fracture started, and when it broke with respect to your process. And it's really important because sometimes you make assumptions, it broke because of this, when that wasn't the problem at all. It was a low cycle fatigue issue, and you think it was an overload, but it wasn't. It was a low cycle fatigue that eventually ended up in an overload situation. So you put a Band-Aid on this thing, and you don't actually fix the root cause, which was what was causing that low cycle fatigue.
So the root cause may not be some fundamental issue at the foundry where this piece of metal was originally forged. Interesting. Okay. Yeah. It might be,
it can be something in the process or how this thing is being used that, so subtle that, the normal person, the normal classically trained engineer may miss. And that's the beauty of it. You can tease that out. And that's the beauty of the metallurgist, right?
That's very cool.
Yeah. It's a lot of fun. I really enjoy it.
So you mentioned this low cycle fatigue. I mean, I know you just kind of threw that out there, but what are some of the problems that you see as you're doing these root cause analysis for metallurgical failures?
Well, typically when you're talking low cycle fatigue, somebody's used a weld where they shouldn't use a weld, or somebody's used a weld and not done the full process that you need to do a weld. Right? Sometimes certain welds are fine if you fully heat treat them, right? If you don't fully heat treat them, then it becomes a stress concentrator. And next thing you know, the normal vibratory cycling of the system, say an amusement park ride, would be fine, except you didn't post-weld heat treat it. So now that weld is a stress concentrator, and next thing you know, a fracture starts. And once it starts, that's the end of the day.
Interesting.
And so that's why we put a lot of emphasis on, you'll hear when in certain aspects, you'll hear about people saying, "Ooh, don't weld on this." Like you'll see that on a car frame. It's like, do not weld on that car frame. Like certain car frames and things, they'll be like, don't weld on them. And the reason is because you can weld on them, but you have to post-weld heat treat it in order to make sure the
most people won't think to do.
No, especially if you're restoring a car or something.
Sure. Yeah.
Yeah.
Okay. Well, what are the metallurgical problems that you solve that you're most proud of?
Oh, wow. I don't think I can I can't put my hand on a single type of problem. I really enjoy just the fact that as an engineer, our job, Aaron, your job and my job, our job is to solve problems for people that don't know how to solve them themselves, right? So you are you're mechanical engineer, I assume. And so you can solve those sorts of problems. I'm a metallurgist, so I'll solve problems related to metallurgy. And when somebody's got a really bad problem and they're like struggling and they're slamming their head against the wall. And I'm like, hold on, slow down. Let's back up and just look at this whole thing. And when I can say, you see this little detail here? I know it doesn't mean much to you, but it actually matters. And you didn't know, and that's okay. Let me educate you. And if I can take a half an hour on a whiteboard and show somebody why they're having their problem and they get it, I'm so happy, right? So that's really when I get fulfilled. It's like, okay, you understand where I'm at, you understand the problem, and now you can go and fix it. And that is probably the most important thing I can, the most enjoyable thing of our jobs.
I think I've often defined an engineer as a professional technical problem solver. And I think that, at least me personally, I find so much joy in helping a person understand how to solve a problem themselves. And I wonder if there's something about that that's not unique to engineers, but do engineers take more joy in helping people solve their own problems than, I don't know, some other profession? Have you had any experience with that, or have you seen any patterns or trends, or even just with your own experience noticed that one way or the other?
I don't know if it's unique to engineers. I think we all want to help each other, right? I think overall, we're all, everybody's good. We all want to do the right thing. We all want to be helpful and be useful. And I don't think that's unique to engineers. I would argue that anybody is like that, deep down. Maybe they're blinded by money and they're, putting on airs and stuff. But I hope, I'd like to think that everybody has that overall inherent want to help people. I hope so. I hope I'm right. I could be wrong, but
yeah, part of the human DNA, right?
Yeah, exactly.
What makes our species who we are. I mean, we got here by helping each other, right? If we were tearing each other down every hour of every day, we wouldn't be where we are right now.
No, I agree. I agree. Sometimes we do tear each other down.
Sometimes we do.
But I don't think it's intentional. Well, I think it would be different depending on how the interactions happened. How's that?
Yeah, context plays a big part, and
it's a little deep here. Yeah.
It is. But hey, it's the end of the day, and here we're getting into deep stuff.
Oh yeah.
Have you followed Tesla's gigacasting at all?
Just a little bit. Just a little bit. And it's funny. I worked in a foundry for 5 years, making investment castings. And so I got to learn from some very talented people, a lot about castings. And when I just looked at what Elon was trying to do with this gigacasting, and I'm just like, there's a lot to overcome there, because you've got thermodynamics, so you got thermal transfer issues. You've got to get that metal to where it's got to be before it goes solid. Right? So you got alloy considerations, because depending on your alloying, you can actually keep a casting slushy for quite a while. Slushy. Okay. And so and if you've got enough force behind it, you can just fill your cavities. And actually that's what you would want, right? You would want it to be slushy so that you don't have too much thermal transfer to get it to solid. Right. And
right. Yeah.
The more thermal transfer you've got, the more possibility of shrinking in cavities and that kind of stuff. And so it's a hell of a challenge, especially to cast something like he's casting. And then think about it from a tooling standpoint. You've got all these pulls, like that thing has got pulls, and they have to be timed perfectly. And, Aaron, you've probably worked with some really good tool makers in your time. But a really good tool maker they are the most brilliant individuals, I think, in our society. A really good tool maker is, I feel often we don't give tool makers the credit that they are due, because those individuals can visualize a 3D situation analyze it and say, okay, I'm going to build a tool right here like this, and I'm going to make my cuts here, and I got to machine it perfectly so it fits in the slot. And we would say, oh, well, you can just do that with a CNC machine. You know what? Yeah, you can. If the CNC machine helps, it makes things easier, but still at the end of the day, the craftsmanship that a good tool maker can build. And when I see that casting that Tesla's making, I'm just like, whoa, I would love to have like an hour just to watch that tool moving and to see how the tool maker put it together.
I would pay hundreds of dollars to watch a documentary of how that process was developed. I think it would be fascinating.
Yeah. And when you think about what Elon's doing with the Gigafactory and with the Gigacasting and all that, and you compare it to what we did as North Americans, right? Canada and the United States during World War II and the subsequent in the 60s, and some of the stuff that those guys and gals did with like slide rules and common sense and good engineering, and they didn't look at it as like, oh, we can't do this, that's too hard. They just said, yeah, we're gonna do it. We gotta do it or we're dead. So we'll figure it out. And it's so impressive, right? It's so impressive. And I think one of the things that Elon Musk has done is he's captured that can-do attitude. I don't care, what the cost. We're gonna get her done, and then we'll reap the benefits later. Now,
yeah, Well, speaking of process development, that is something else that you have quite a lot of experience with. Do you feel like within the umbrella classification of engineer or even mechanical engineer, is one engineer as good as the next when it comes to process development, or is there a specific kind of a subset of skills that makes a process engineer particularly good?
No. I don't think so. If you had asked me 10 years ago, I would have probably had a different answer. But I don't think the education, right? The education that we go through, right? So our education, we learned how to solve problems, right? I learned how to solve problems in metallurgy. You learned how to solve problems in mechanical engineering. But I think for a process engineering standpoint, it's a mindset, right? Like I'm a metallurgist and I'm solving problems in areas of chemical engineering and electrochemical engineering. I don't know, I was never classically trained in those, yet here I am building. I think about it like a neurological model, like, the AI models where you have a series of inputs and a series of outputs, and then you have some, neurons in between, which I think that's just fascinating. Everybody's afraid of it, but they shouldn't be. And so you put the inputs in and you compare it to the outputs and you build the model in between. The difference between AI and FEA is FEA, you know the math. AI, you don't know the math. And it just makes up a model. And so I've done that for some of the processes like electropolishing, right? I've got a mathematical model in my head that has no science behind it. It's just we call it intuition, right? And I would argue that any engineer can do that. You don't have to be a mechanic. You don't have to be a metallurgist. You don't have to be an electrical engineer. You just got to have the passion and be open to the prospect of, well, I may not understand the science of what's going on or all of it, right? Key statement there. You got to understand science, but you don't have to know it all to be a process engineer. You've just got to be willing to watch and learn and understand and build your own model of what the process is doing. If that makes sense.
Yeah.
Does that make sense to you?
It does. It does. I agree. I think that there is a particular mindset that does especially well with process engineering, and I think they're very closely related to R&D engineers. I think it's kind of the same mindset, in my opinion. That mindset of giant creativity, right, and a desire, almost an inclination towards trying things with the expectation of failure, right? Whereas others may just want to do something that they know is going to work.
One of the things I tell the young engineers that I've worked with over the years, I'm like, if you're not breaking stuff, you're not trying hard enough. right?
Yeah, if you're not breaking stuff, maybe you should be a sustaining engineer.
Yeah,
like
exactly.
That. We don't want our sustaining engineers breaking things.
Well, yeah, but even I agree with you and I disagree with you. Sometimes a process is never fully baked. Right? Process is never fully baked and stuff happens. And I think a sustaining engineer, should go out there and be like, my process is broken and I don't know why. I'm going to try this. And if I break it more, oh, well, it's still broken. I think in troubleshooting, you should be allowed to break stuff and you should be given the freedom to make mistakes. And I think it's important. I think a sustaining engineer has just as hard of a job as a guy developing the process, because I live in both worlds,
In my opinion, that's where the fun is, right? Being able to break stuff and try new things and see what happens.
Yeah.
Well, speaking of processes, here's my shameless plug for my company, Pipeline Design and Engineering. Let's not forget that, sponsor of the Being an Engineer podcast. We are referred to as integrators, often machine builders, automation, and certainly that's what we do. But really, I think we're process developers. That's where our core strength is. And then we're very good at building automated machines, so we can build the automation around said processes and put it together a complete production automated system. But let's move on with Jonathan MacWilliams today. Jonathan, your role now is distinguished engineer. That's your role title. What does it mean to be a distinguished engineer?
That's a great question. When you find out, let me know, will you? So at Edwards, right, they have tiers of engineers, right? So I am engineer 5, I think. Yeah, level 5, right? So I got distinguished and senior distinguished. I think I look at a distinguished engineer as a recognition of, one, my education, right? And more importantly, my experience, right? So I've had experiences in foundries. I've had experiences in medical device. I've got over 20 years now in medical devices. And specifically I did the classic thing that they say never to do. I pigeonholed myself into cylindrical, laser cut, electropolished medical devices.
That is very niche.
It's a very niche thing, right? And I'm glad I did. And I'm sure I will continue for many years to come to still be cylindrical, laser cut, electropolished medical devices. You know what I mean? And frankly, I'm okay with that, because, I go to sleep at night knowing that I'm doing something good and I'm helping somebody who can't help themselves, right? Especially a patient. They can't, a patient can't fix themselves. And so I do a little bit, every day, and I help somebody have a better life. And that's, so I think the title is just recognition of my experience and my passion around doing what I do. I think that's about the only way I could describe it.
That's great. Well, you can't get better sleep than that, can you? Going to bed at night, know that you're helping people.
That's right.
Back to that human DNA.
Yep.
Technical responsibilities are not the only thing that you're focusing on these days. One of your core focuses is developing technical leadership and mentoring programs. What have you found are maybe a few of the biggest obstacles that engineers encounter when they're trying to develop those leadership skills?
Well, okay, that's a great question. So let's just be honest. Yeah, Aaron, you and I went to school and we were trained to be engineers. We weren't trained to be people. We weren't trained to manage people. We weren't trained to lead. We were trained to get our calculator out and calculate the moment of inertia about a beam, 12 feet long or whatever. Right? Or in my case, how do I melt 17.4 and not kill everybody in the room? Little things like that. But we were never trained on being managers. We were never trained to be leaders. None of that happens in an engineering degree. And I think that's the biggest the biggest hurdle we have to overcome, is because we'll get high enough up in our career. Eventually somebody's going to say, Jonathan, you're a pretty nice fella and you can do some great engineering. Why don't you take over this team and lead them? It's like, well, wait a minute. You said I'm a nice guy and I do good engineering, and now you want me to lead people? Like, that's a different job description. What are you doing? And some people, I think the overall, what's the word I'm looking for? The overall prevailing thing is like, oh, well, that's what you just do. You get to a point and then you gotta jump over to management. You can't be an engineer anymore. You're driving home from work, take that calculator and chuck it out the window when you're going over a bridge, right? Because you're never using it ever again. And there's a certain amount of truth to that. But some of us aren't necessarily good managers. And I think the biggest hurdle that you've got to deal with is once you go into the management space, it becomes ambiguous, right? What used to be cut and dry, 1 + 1 = 2, right? Or the moment of inertia on this beam is Y, right? That's no longer the case. It becomes ambiguous because now I've got a strategy and I got to do, this is what I have to get done. But if I make this person do it, I'm going to hurt their feelings. And if you can't deal with that, you're not going to be an effective manager, right? If you can't cope with the people side of the equation, right? You're never going to be an effective manager. I will say that till I'm blue in the face, right? Because, management and leading is 50% people and 20% or 50% strategy, in my opinion. As an engineer, if I become a manager, the reason I have an engineering degree is not to engineer, but to understand the issues that my team is having so that I can have a frank and honest conversation with them and say, okay, this is how we've got to get through this. You need to do these engineering tasks and I understand what you have to do because I've done it too.
That does make sense. You and I talked a little before the show about feelings and how engineers aren't necessarily the most comfortable with like expressing our feelings and talking about feelings. How does a certain level of comfort with one's feelings correlate to the ability to be an effective, respected technical leader?
I think it's extremely important. It's interesting. So where I work now at Edwards, it was recognized that the technical folks weren't necessarily staying technical and they were moving over to management roles, because there's a certain belief system, and I would say it doesn't matter what company you're in, change the name from Edwards to J&J to, Boston Scientific or General Motors. It's like, yeah, you're going to peak out. You're not going to be as successful as if you went over to management and led a team and had a big impact. There may be some truth to that, but at the end of the day, we got to be happy with our work, right? We have to be happy with our work. And so even as a technical leader, right? So I've been tasked to do this, and I'm like, well, I don't know. That's touchy-feely stuff. I don't know what that is. And so it forced me to learn about stuff that I had just ignored for lack of a better, when HR has those presentations, Aaron, you got your own company, so you can set your own tone. But when you're at a big company and HR comes in and it's like, oh, we want you to do this, this, and this about your career planning. I am not kidding. It was like in Charlie Brown when the teacher starts talking. Yeah, that's all I heard. And I'm just like, yeah, whatever. Just get me through this so I can go back and do some metallurgy. And if I had known then what I know now, I would have had a different approach to a lot of that training that I went through. So I find myself actually going back and redoing it with my eyes open, and my eyes open and my heart open, I guess you could say, right? Like just lay it on me because I'll figure I need these skills, even as a technical leader. I need these skills because I'm no longer engineering it for the sake of engineering. I'm engineering for the sake of helping a younger engineer come up and be a strong and contributing member of the team. Recognizing that you have to do that is important. It's lost on us. Sometimes we get locked into our head that we have to, either be a manager or stay as an individual contributor. But there is actually a shade of gray in the middle there, and that's where I'm trying to live, right? Because I enjoy teaching.
For the sake of other engineers out there, you mentioned if you had a chance to go back and listen to some of these HR presentations, we don't even have to classify it as HR presentations, but maybe some of the soft skills or the leadership things.
There you go.
What are one or two of those things that you recommend engineers, maybe especially younger engineers, actively go out and try to learn and have experiences with?
Like career planning, right? So the career planning thing is probably the biggest thing I could talk about, because I'll tell you what my career plan was. I didn't have one. All right. I did not have a career plan. It was opportunity, fear, and survival, right? Any one of those three defined my career. So, I got laid off from the foundry. I'm like, oh, what am I going to do? And next thing you know, I got a gig making medical devices, and then I got an opportunity to go to a bigger company, and I just no plan, none. And I'm happy to admit that. If I knew then what I knew now, one of the things I would have done is I would have taken my career plan and taken an approach to not what technical skills do I need. I have the technical skills, right? They were imbued upon me during my degree, and so I have the technical skills. But what I didn't get during my degree was soft skills, like, hey, here's how you deal with a tense situation. Please don't escalate it like you would be apt to do because of your personality. Instead, take these approaches. You know what I mean? And if I had known that, I think of all these times where I got into battles with people over stupid stuff. And I'm like, I could have handled that so much better. And when I say that, battles with people over stupid stuff, that's not very long ago, like maybe 2 or 3 years ago. You know what I mean? I think it's important that if there's one thing I could tell a young engineer, it's like, if you get an opportunity to learn any soft skills, take it, especially if the company's paying for it. One, you're going to get paid to do it, right? So let's just call that out, right? You're getting paid to do it. They understand that you're going to be doing this training. So the deadlines will be somewhat flexible, but you actually might get something out of it. Something that you hadn't thought of. So go in there with an open mind and be ready to absorb something that you weren't classically trained on.
What has been one of the most rewarding leadership experiences of your career to date?
Well, I'll tell you, I fell victim to, over the years, being, hey, Jonathan, you're a pretty good engineer. You got your crap together there. Why don't you go and lead this team? And I'd be like, yeah, I guess so. Not realizing what I didn't know. And so I take these leadership opportunities, and they were awful. They were awful. Absolutely atrocious.
Awful for you or for your team or for both?
But especially for me. I have a bit of a strong personality. You might have noticed. But especially when things get ambiguous, and I don't handle ambiguity very well. Right. It just got thoroughly disagreeable. And to the point where when I came to Edwards, the same thing was starting to happen. And I pulled my boss aside and I'm like, listen, I see where this is going. And you're thinking about putting me into running this part of this facility. Oh, yeah. Don't do it. It'll end badly. And I don't want to do it. Right. And so here I am. It's like, okay, you can stay over there and people will leave you alone. But I realized that was a mistake too. And I was given an opportunity to pursue this technical leadership thing, which forced me to be introspective and realize that I couldn't handle ambiguity. All right. So Okay, I'm 51. All right. At 50, I figured out I couldn't manage ambiguity. Think about that for a minute, Aaron. All right. So I've been practicing engineering for almost 30 years, and I just now realized that I can't handle ambiguity very well. That's half the battle.
That makes me feel better about myself, Jonathan. I feel like I'm a slow learner and like, wow, I should have realized this about myself 20 years ago. So I appreciate your candor and your vulnerability.
Oh, yeah.
Right? And very much.
And so once I recognized that I had this issue, I could vocalize it. And so when I was interacting with people and they were like presenting me with issues, and I could tell them, like look them dead in the eye, I was like, I don't handle ambiguity very well here. So I want to count on you to help me get through this decision-making process that we've got to do. And so I turned it from Jonathan, the decision maker, to Jonathan, the vulnerable guy that has a lot of experience. Can you help me work through this? And it actually has been more fruitful than just sitting back and being the oracle. This is what you will do. And instead trying to take let's work on this together because I can't handle doing this by myself. And the team that I'm working with, the other engineers, they're like, okay, we get it. We understand. Let's work on it together. And they actually appreciate the fact that I'm not perfect. And I appreciate the fact that I'm not perfect, but
there's a book called The Culture Code. Wonderful, wonderful book. One of the best books I've ever read about building a team and a culture. And the author investigates a myriad of different situations and teams and circumstances. And he boils it down to 3 pillars that are most influential in creating a culture, a positive culture. And one of them is sharing vulnerability. So I thought that was pretty amazing. All the things that he studied, sharing vulnerability was one of the 3 most important factors that led to positive, meaningful cultures in whether it's a company or a family or a sports team, whatever.
I believe that. I believe that to be true. Especially with how impactful it's been for me to admit where I'm weak. It's you got to admit where you're weak. Yeah.
Well, on the subject of growth, I mean, you've accomplished quite a lot in your career already, and of course, there's always more that we can learn and more that we can grow. What's an area right now? You mentioned recognizing you don't deal well with ambiguity. Maybe beyond that, what's another area that you're trying to improve yourself right now?
Well, right now my focus is on the ambiguity. That's a big thing, and it's funny you mentioned that. So at Edwards, they focus on there's a Corn Ferry. It's a consulting firm, and they have these 30 some different aspects of life and business, right? And it's like managing ambiguity and, driving the team and a bunch of these keywords, the Charlie Brown, wah, 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 right? And I've stopped doing the wah, 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 and I've kind of looked at them and it's really nice. They give you the topic and then they tell you, if you're good at this, you exhibit the following behaviors. If you're bad at this, you exhibit the following behaviors. And if you're really, really just too good at this and you're overusing it, these are your behaviors, right? So the first one was managing ambiguity, and I'm working on that right now. And I'm actually, they've started the process of forcing us to, be introspective yet again, because it's coming up on the end of the year. And I literally just got the email, hey, it's time for you to take a look at what you want to work on for next year. So I honestly can't answer that question right now because I've been so focused on this component. I haven't really thought about anything else.
What are some ways that you're going about working on this issue of ambiguity? Help us, maybe walk us through your process and in hopes that maybe that might inspire others.
Because I've recognized it, that's half the battle. Once you understand you have an issue, that's half the problem or half the battle. Because now that I understand it, okay, I've got a problem with ambiguity. And when I see stuff becoming ambiguous, I can be like, I can hesitate for my gut reaction. You have that guttural reaction, right? Like, I am gonna, like, you're gonna say something that you may regret because you've got this fear in you of like, this is ambiguous. This is ambiguous. You don't know the answer. You have to have an answer, right? Because you're Jonathan, the 30-year veteran engineer, 27 years, whatever it is. Like, you have to have an answer. If you don't have an answer, why are you here, right? So I've got to take those gut instinct feelings and suppress them down so that I don't give that passionate, snap, not necessarily not politically correct, but not kind, that unkind response, and instead step back and say, okay, things are getting ugly. I need to take a break here. And to a certain extent, vocalize that to whoever you're interacting with. It's like, okay, things are getting a little, are freaking out here, and be able to say that. And actually it really helps. It really helps because the other party's like, oh, okay, I get it. I see where you're at. And then we can they can help massage the conversation so that I can start to, and I can ask the right questions and, step back. And I think that's probably, half the battle. You need to know where you're weak. You need to know where you're weak, admit where you're weak, and then understand when you get into those situations so that you don't do something dumb.
I love the way that you put that. It makes me think of, we have some tenets here at Pipeline, some philosophies, right, that we try to live by. They're hanging up on a wall. There are, I think we have 9 of them or maybe 10. Anyway, one of them is take what's on the inside, put it on the outside, and talk about it. And I've found this to be so, it's exactly what you were just saying, it's recognizing a feeling that you're having and then expressing that feeling. And just the other day, there was a minor concern with one of our team members here. And I was thinking to myself, man, what am I going to do about this? How am I going to approach this? And I thought to myself, oh, it's the tenet, take what's on the inside, put it on the outside. So I just approached the team members and, hey, you know what? I've got this mild concern. I think we should talk about it. What do you think? And we had a great conversation about it. Just getting that out there and into the open is super, super helpful. And people really appreciate that.
Yeah. I think you're right. Yeah. Sometimes you just got to talk. I think sometimes we make things too complicated. We put on our little, we're a Ken doll or a Barbie doll, like we're plastic and we're perfect, we put that on, we have our synergy and stuff. And sometimes I think we just need to have a frank conversation. And I think you should be allowed to have a frank conversation, not insulting. Now, frank doesn't mean insulting. Frank doesn't mean, hurtful. We don't want to hurt each other. We're all in this together, right? We've all got a job to do, and we want to make the world a better place. And so, if we're not seeing eye to eye, well, let's talk about it. Maybe we can figure things out and work together and solve it. And I've taken that approach, and it's helping me.
And in fact, I think that when you're having those frank conversations, it calls for being extra respectful and extra kind and polite,
Absolutely.
Right? And that gets down to just the words that you use, just lots of pleases and thank yous and kindergarten skills, right? Yeah. We call them sometimes. I think that people really, they appreciate that. And when you're feeling that, that anxiety or frustration boil up inside of you and you're not sure how to handle it, that is exactly the time when you take what's on the inside, you put it on the outside. And
I like that. I'm going to keep that. I'm going to use that.
It was passed on to me by someone else. So I take no credit for it, but I sure have found a lot of value in those few words there.
And it comes back to, you just got to be nice to each other. Right? We're not trying to, 99% of the time, we're not trying to hurt each other. Anything that does come across as hurtful, in my experience, it's unintentional.
Totally. Yeah. All right, Jonathan. Well, I've got one more question for you, and then we'll wrap things up here. Specifically within the context of your role as an engineer, what is one thing that frustrates you? And conversely, one thing that brings you joy?
Well, it's the same thing, if you can manage that. So if you think about this, Aaron, we are standing on the shoulders of giants, right?
Definitely.
There was metallurgists that came before me that spent their entire career working out something. And so Leonhard Euler, right? You know who he is? Euler?
I do not.
Yes, you do, because he's the guy that figured out the moment of inertia calculations and all those formulae that you use, that you have memorized, and you can just whip them out as a mechanical engineer, right? Yeah,
exactly. Yes, everyone out there, have them all memorized, 100%.
Yep. But
definitely,
that was it. That was his life's work, working on those equations and quite a few other things, mind you. And then we just use them as routine, right? They're just routine for us, right? So we're standing on his shoulders. And
absolutely,
what frustrates me is the old engineer, right? They might be listening. They know who they are, all right? I was one of them. And where we're just like, you young guys, you don't know what you're doing. You have pug kids. You know, your education is like, whatever, you know, get out of my face, get out of my office, go learn something, come back, right? We've all met that engineer, right? We've all met him or her. And that person, I was going down that road. I'll admit that. I was going down that road. And then they asked me to be technical leader, and I started to really think things through. And I'm like, oh, geez, don't do that. Don't do that. And so that annoys me. When I see somebody behaving like that, that annoys me. But on the same token, however, that if that same engineer is just like, you know, like here. All right, so I graduated in 1995, Aaron. Right, so my software revision is 1995. I have somebody that just joined my team. Or, yeah, I say my team. Yeah, my team. Why not? It's my team. They're all my peeps, right? They're all my friends, and they're all good engineers.
Right.
Well, she just joined the team. She graduated in 2002. So her software revision level is 2002. Okay? Now, what we forget as the version 1995, we have certain subroutines, certain things that we learned. Like, you know, I learned about, you know, metallography using optical microscopy and how to pipette those samples. Well, version 2002, they've deleted that subroutine and replaced it with something much more current and much more effective, right? And so when the old 95 guy, you know, Windows 95 over here says, well, you should be using Hyperterminal. And they're like, what? Go easy, old man. Like we've graduated to something better. We've got Windows Explorer here, or whatever. And it's important as we get older, you know, we need to understand that the shoulders that we're standing upon, eventually we become the shoulders, and we have to pick those young engineers up, put them on our shoulders, and push them up so they can be more successful than we are. Right? That's absolutely critical. I don't care who you are. I don't care what kind of engineer. I don't care anything. That is our job. Eventually, we get to a point where our job is to help a young engineer succeed, no matter what the cost.
I love that. You know, it demonstrates a high degree of just caring and thoughtfulness. And honestly, it reminds me of being a parent, right? We want our kids to be better than we are. And that's just an indication of care and love for the people that we work with.
And plus, I can't retire. If I don't teach them everything I know, I can't retire. Right?
Yeah. Great point.
No, but I think it's important. And I think, you know, so like when I can push some of my knowledge, right? So I'm at version 1995 with this huge database. If I can take some of my database and copy it to version 2022, then I've done my job. I've done my job, right? That's it in a nutshell. Like we as seasoned engineers, we were taught when we were, at one point, we were those young engineers. And somebody took us under their wing, be that a professor or whatever, and they said, check it out. This is what you got to do. And we foundered and we made mistakes and you know, and some of the guys would laugh at us and say, you're dumb. But a lot of them didn't. And a lot of them got it. And they're like, you know what? You just learned a valuable lesson, son. And you'll never do that again. And I take the approach of, you need to learn, and I'm here to help you. And I want everybody to do that. I think everybody that's listening should just think about that for a minute and remember there was somebody that helped them. And it's always time to give back.
I love it. What a great message. Jonathan, this has been such a privilege and a delight talking with you today. Thank you for the stimulating conversation and the wonderful message that you've shared with all of the engineering listeners out there in the community.
No, thanks for, Aaron, listen, Blake, thanks for having me. I really appreciate it.
You're so welcome. How can, after listening to this, I bet there are going to be some people who would love to talk with you one-on-one. How can people get in touch with you?
Probably the best way is to find me on LinkedIn. I've no doubt, Aaron, that somebody that's listening to this will be able to find you on LinkedIn and find me, or however. Sometimes I can't find people on LinkedIn. The other way to get me, if you can be patient, let me wade through my inbox, is my email. It's jonathan.macwilliams@gmail.com. And that's Jonathan, Jonathan, and MacWilliams with M-A-C. People forget that.
The A.
Scottish. Yeah. So, you can send me an email. No guarantee on the email because I was just looking at it and it's like, wow, I've got 2,512 unread emails in my inbox.
All right. LinkedIn it is.
LinkedIn it is. Yeah.
All right. Well, Jonathan, thank you again so much for being on the show.
I really appreciate it, Aaron. Thanks for asking me. And I'm glad we had this opportunity to connect.
Likewise. I'm Aaron Monker, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, visit us at teampipeline.us. Thanks for listening.